Alright, let's do another problem. So our first problem of the day is going to be LeetCode number 200, number of islands. Given an m by n 2D binary grid, which represents a map of ones, which are land, and zeros, which are water, return the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume that all four edges of the grid are surrounded by water. Okay, so let's see. So we have an m by n grid. We want to return the number of islands that exist within that grid. A condition that we are given in this problem, which may not be specifically given by an interviewer, would be that the edges present water. Let's see. So my first instinct here is to do some sort of BFS or DFS type thing. BFS or DFS when we encounter an island. The idea is that if we haven't seen this island before, then we should denote it and fill in all of the spaces that it contains. If we have seen it before, then ignore it. Right? So I think in technical details, what we could do is that first we would copy over the grid, but if a cell is land, mark it initially as -1. And -1 in this case will represent our unexplored tiles. Then, iterating over our new grid, if we encounter an unexplored tile, perform essentially what is a flood fill on that chain of land. And this flood fill will use a number which is then incremented. So essentially, if the number is unexplored or marked as -1, we will perform a flood fill within that chain of islands no matter how large it gets, right? And then, when we iterate over the other cells, if we see a number which is not -1 and not 0, then we know that that island has already been visited. And so we do not need to mark that as another island. In this case, in the initial iteration or copy of our array will be, or of our matrix will be O of n squared. We could perform, actually, we'll do m times n for this, right? Because the grid, the matrix may not necessarily be a square. Now, our BFS algorithm for each one. Let me think. Assuming that we just have one giant island, right? Well, we need to iterate through probably all of the cells. Through all cells within our new matrix. Plus, if we have to perform BFS on part of them, right? Well, if we perform BFS, at most we would have to scan through all m by n for BFS, I believe that it would be just an m by n additional, and not an m by n. Right, because if we do the m by n BFS, and it turns out that the BFS goes over all of the cells, right? If this entire matrix was just an island, which is a singular island, then we would not need to perform BFS on any of the subsequent cells. We would just be iterating over them. So that would be addition. I don't believe that this goes into the realm of multiplication of, like, we're not performing BFS specifically on each cell. And if BFS were performed on, well, it would have to be performed on every other cell, right? In sort of like a checkerboard fashion. In that case, we would just be doing that one operation for each, if we wanted to maximize the number of BFS calls. So I think in this case, our algorithm probably runs within the O of m times n range, where of course m and n are the dimensions of the matrix. I'm not entirely too sure on this, and maybe there's a better solution. However, I don't think that we should skip our iteration in our second pass based on which cells that we visit within our BFS. Because if we have a situation like this, let's say 1, 1, 0, 1, 1, 1, 0, 1. Actually, this would be a bad example. We'd do 1 there and a 0 there, right? And then we can say 0s. That doesn't really matter. If we go here and then we do the BFS and we discover this like one big island, right? These 5 cells right here. And then we skip to the next one, well, we'll entirely miss out on this one. Missed if we skip our iteration to the end of our BFS. So that's not something that we necessarily want to do. We want to really just iterate through each cell. And I think at this point, this is like a pretty decent solution. And we can think about it a little bit more, but I think this is the solution that I would start with. And so with that said, let's get coding. So our first thing to do is to actually get our island grid. So we'll say val island grid is equal to a list of this is a character. We'll do integers just to make it easier on ourselves. This is of size grid.size, and then we will create a list of integers of grid at let's see. Grid. We would need our index, and we would need our grid at index.size in that case. And let's just make sure that this is that we can actually do this. No value passed for parameter init. We can just say 0. We'll just initialize everything as 0 for now. This seems to work fine. Cool. So now we can say that actually what we could do is that we could be a little bit cheeky about this. And in this case, we have the index, right? We have the column. And then now what we can do is that we could mess with, let's say, the row itself. So now we have access to a row, and we can say if grid at column and row is equal to 0, else, so we can say 0, and this is -1. And then we can say island grid dot for each, and this is going to be our inner list, and then inner list dot for each indexed column. This should be indexed as well. Row value. We can say print line or print our value. And then we can print line here. So this is like this. Right, so this is the first example that we plug in. So we see our row of -1s, 4 of them, and then 2, and then another 1, and then 2 on the last row. So we're in good shape for now. Let's also grab a queue because we're gonna need a queue for our BFS. So we'll say mutable list of, let's see. We're gonna want a cell, and we're gonna declare a data class cell with a val column, which is of type int, and a val row, which is also of type int. Not sure if I need to toss the brackets there, so we'll just do that. And this cell will just create a cell starting at 0, 0. Actually, no, we don't need to create a cell at 0, 0 because there's no guarantee so far that that 0, 0 will have an island on it, right? And actually, now that I think about it, we might want to modify one of these for eaches because of the fact that Kotlin is not a fan of concurrent modification when you have this value right here and then you modify it. We'll see. We'll see. It might be this inner one that we had to get rid of. So for each one, if the value is not, or it's not 0 and the value is not -1, or actually we can just say if the value is -1, right? Add to BFS list. And if the queue is not empty, then while the queue is not empty, and actually I could probably take the first part out, we can say that the val front is the queue dot first, and we can say queue remove at 0. We can just take this part out. There's no need to do that. Right, we can say front dot, so we want to get the island grid at front dot column and front dot row is equal to our accumulator, we'll say, and this will start at 1. actually, this will start at 0, and this will be +1. And then we will also have a flag here. And let me just remind myself to do add flag to see if we need to increment the accumulator. So the job of the accumulator is basically to actually just hold track of the number of islands, individual islands that we've seen. If if front.column -1 is greater than 0, and on our island grid, our front.column -1 and our front row is -1, we can add a reference to our front column -1 and our front row. And we'll do something very, very similar to for our row. And then our column +1 is less than our island grid dot size. And then our row +1 basically we are adding our islands in our 4 directions if they happen to be unexplored yet, right? So basically we're just filling in all the islands that are connected to this current island by adding it to our BFS queue if it happens to be if it happens to exist. Let's see. +1 should be less than island grid at front.column dot size. The row value is always a little bit awkward, but believe that should be the case. Let's just scoot it over so it looks a little bit better. So now we can say that q.add a cell at our column and row. And actually, we can increment our accumulator there, right? Because we know that we've found a value that is unexplored. And then this is our sort of other step of flood filling the values. Connected pieces of land to our current island. And then we just pretty much increment from there. Rather than doing this, we can do print line found new island at column row. And then we can also say found connected land at front.column -1 front.row. We can do something very similar in terms of our print statements for debugging purposes on these other cases. So this is +1. This is -1 on the row. This is +1 on the row. We don't need this print line statement here for now. And then this accumulator is pretty much just the number of islands, right? We could call this num islands if we really wanted to, because that's really accurate. That's the most accurate way that we could sort of depict this. And And of course, we can actually remove that +1 there from our accumulator, because our accumulator will increment as soon as we find a new island. So this will cause a BFS to pretty much propagate throughout all the islands, or all the pieces of land that are connected to it, so that when we run through the rest of the islands within our grid, then we won't double count any of our islands, or that we should not. Of course, another thing to talk about is also our space complexity, which is something that I did miss in the beginning. But yes, this solution will take O of m times n space complexity, which perhaps is a little bit big. We are essentially creating a copy of the matrix, and maybe there is a way to sort of make it so it doesn't take as much space, but this is sort of my basic solution towards this problem. Let's see how it handles. First of all, the first example. Let's see. Island grid. I see. Let's see. So it seems like it doesn't really like the fact that our island grid is setting a value within here. No set method providing array access. We can set this to be a mutable list, and we can set this to be a mutable list. I believe the main problem is just the fact that it looks like we have an out of bounds exception. Front row less than -1 is greater than 0. I didn't change that. Okay, let's double check now that we've actually set this up. So we found a new island at 0, 0. Then 1, 0 and 0, 1, we have more islands. 2, 0 and 1, 1, and then so on and so forth. So it seems like it worked for this one. Let us run the other example, the second example, where we have a total of 3 islands to explore. So we found a new island at 0, 0, which is correct, with a new land at 1, 0, 0, 1, and 1, 1. Oh, it seems like we're doing a little bit of overlap here. We found the new connected line at 1, 1 twice. Probably because this is adjacent to both 1, 0 and 0, 1. So we probably want to avoid that. So we can say if front or island grid at front column and front row is still -1, right? Then we do all of this fancy stuff, because otherwise we might actually be wasting a lot of our time, because we are going over a cell that we have already visited and we have already painted. So actually we could do, rather than that also, we could do actually, this shouldn't be happening, right? Because we are checking that the value is -1. Interesting. Let's see. No, because this is just checking if it's -1, but it doesn't actually get painted until here. I see, I see. Yeah, so this isn't broken. We find a new island at 2, 2. We find a new island at 3, 3. 0, 1, 2, 3. 1, 2, 3, which is this cell. And we found connected line at 3, 4. So I think this actually works fine. So let's go ahead and comment out our debugging. And then let's go ahead and toss a submit, and let's see where we end up. Ooh, interesting. Looks like we have a different case here. What does this look like? 1, 1, 1, 0, 1, 0, and 1, 1, 1. We had an output of 2. If it's greater than or equal to 0. Small mistakes like that are probably what are going to cost me the technical interviews. But yes, we are 0 index, so we want to be really sure that we are dealing with greater than or equal to 0 or less than the size, because it goes to size -1. Okay, so the runtime seems to be a little bit high with the memory usage. The memory usage actually pretty fine. I had a bad experience with the hotel Wi-Fi when I did my LeetCode there, so I'm just going to double check. Okay, so it seems like our solution is pretty average, to be honest. After rerunning it a second time, guessing that LeetCode just with the cold starts, like sort of submitting for the first time, sort of includes their sort of startup time, which is a little bit strange. I don't know, or maybe it's not that's not a thing. But in any case, this is our solution for now. I think I'm gonna leave it here for now. I'll think about it some more if I have anything else, and I'll leave that in the comments. But other than that, I hope you learned something, and I'll see you for the next problem.